Hey there, guys. This is the one that you've all been waiting for, the how to scan pixels really fast. I mean, there's one option that you can do, which is the when you have an image, you can use the image dot get pixel, and that would just look like bmp dot get pixel, and then you would put in your coordinates x and y, and it would return to you the uh, the pixel color. So this would be something like color from ARGB equals this pixel. That's how that would work. The other option, though, is that that's not too fast. So what you want to do is you want a fast thing that works really fast. If you want a 640 by 40 image that's live, updating, changing the image, or looking at the image, determining something, you need a fast method to do that. Now, this code here I have is basically from another program I did. It's already up on YouTube. That when you click play, it follows my cursor around and just records from the screen where the cursor is. And that's the screen capture video I made. Now, what I want to do is, since I have my image and it's going to the picture box, this is a big picture box right here, I want to change this image really fast, live updating. So here's the chunk of code. And this is the only code I'm going to put in the description, not the rest of the stuff. You can get this otherwise. But here's the big chunk of code. It's pretty decent size. It is this mess right here. Now, the reasoning behind what this code does is that when you have a form object being a picture box, a picture object, or even if you weren't doing this in picture format, but say text or anything that has a lot of data in it, what you want to do is you want to throw that to an array, because an array works a lot faster than referencing that form object and then pulling the data from that form object at a certain point. And pictures are a big representation of this. So what happens here is we're defining the area that we want to grab, and we're putting it into an array. This is this RGB values thing. And this, what that whole thing does right here is it puts RGB values into an array. Here I have some other things, like I called it second counter. That's versus first counter, which I don't know where that ever went to, but what second counter is, it's the in this array, it starts off with blue, green, red, and alpha. And that's every 4 bytes is blue, then green, then red, then alpha, and then the next pixel happens. And what we're doing is the second counter is that array of all those bytes. So let's see here. 640 by 480 times 4. So there should be, 1,200,000 some odd bytes in this thing. So that's what second counter is counting through. Now, this little chunk of code here pulls those out and puts them into temp blue, temp green, temp red, and temp alpha. With that, we can go through and say if my temp blue is this, or more than this, or less than this, do this. I've also included some code in here. This took me a while to figure out, but I got it. This determines how or what position you're actually looking at of the pixel you're currently looking through. This will give you the X and the Y with that. And then here's where you put your code where you want it. And then RGB values, you take the temp blue, temp green, temp red, temp alpha, put them back into the RGB value, up your counter by 4, and then loop again. And this, for every loop, is 1 pixel worth. And through the end of this all, it puts it back into the BMP from the array back into the picture image. So, all that said, let's make some code out of this. So, here's how you would use this. If temp red is greater than 200 and temp blue is greater than 200 and temp green is greater than 200, then I want to change temp red to nothing. Temp blue to nothing, and temp green to nothing. Now what this is going to do is anything that remotely resembles white is going to be changed to black. And you notice I didn't do anything to temp alpha. Temp alpha I set right after I grab it. And it's just 255. If you set alpha to 0, you get no color at all. So just as simply setting red, blue, and green to 0, temp alpha gets, if that's at 255, it's still going to be turning black. So I don't bother with temp alpha at all, really. I guess you can if you want to, I just don't. So anyhow, this is the new code that we've added to my current program. Alright, hit play. And oh, look at that. That's neat. Move this over here. Yeah, everything that remotely resembles white is turned black. And you can see my code all right there is turned black. Now let's see. Go to the front page of YouTube. We can see how this will work. Yeah. See how the background and everything, all these images have changed to black? Pretty cool, ain't it? So with this then, you can, for tracking software that I've made, in this portion of code right here, I say if I have an area defined, if it's within this area and it's within this color range, then record this X and Y, and then with that X and Y you can get a position from that, and then your imagination's just good from there on. So this is really powerful, really fast, and it's the best way to change an image to how you want it to work and what you want to do with it. And this is the key to how I made my tracking software that everyone seems to want to know about. So there you go. Have fun with that.